So I'm gonna hit record. Topic of today is Bronsted Lowry acid base. So we know the Arrhenius definition. An acid is something that increases the hydrogen ion concentration, and a base is something that increases the hydroxide ion concentration. So there were two guys, Bronsted and Lowry, and they came up with these independently. I think Bronsted has that cool bow like that too. They came up with this independently, and they actually sent their theses and their documents to the chemistry council at the same time, like within days of each other. So they attribute it to both Bronsted and Lowry. I like to think of it, and you guys actually just made one of those movies again, but have you guys ever seen Bad Boys? No. The original Bad Boys is like the one guy plays the part of the other one. They go, Mark Lowry. Can't believe you guys haven't seen that. So I used to call it Bronsted and Lowry, but Bronsted and Lowry. Acid base theory. It's lost its ring if you haven't seen the movie. Hudson, you seen those Bad Boys? Got that Will Smith and Martin Lawrence?
I'm not.
You what? Yeah, you saw the last one. You gotta go original. It's got Tia Leone in it. So if we take a look, Bronsted and Lowry determined that there are some chemicals that don't look like typical acids or bases. So we have something of NH3, for example. If we add NH3 to water, sodium, the water, the nitrogen trihydride, or what we call ammonia, takes a hydrogen from the water. And that forms an OH. And the ammonium ion. So that forms that. So does it increase the hydroxide ion concentration? Yes. But does it have an OH on it, like the Arrhenius idea? No. So is this a base? Yes. The Bronsted Lowry came up with the same idea separately, that so an acid like H2O here, we don't consider H2O an acid, it's neutral in our mind, but in this case, it is adding a hydrogen to something. So it is what we call a hydrogen ion donor. It gives the hydrogen to the ammonia. And the base is known as the hydrogen ion acceptor. The NH3 is gaining the hydrogen. Now, if you lose a hydrogen, you're also losing a positive charge. So automatically, if you lose a positive charge, what is your new charge? -1. It only changes by 1 because you only lose 1 hydrogen at a time for this. If you gain a hydrogen, you're gaining a positive charge. So what is your new charge? If your charge was neutral here, then it is +1. So Bronsted Lowry would call this an acid and this a base. And whenever a base reacts, it has an extra hydrogen now. So that is called the conjugate acid. Bases yield conjugate acids. And acids, guess what? We have hydroxide. Well, that's going to be a conjugate base. Each side has one. The acid becomes a conjugate base. The base becomes a conjugate acid. Because what's it do? It's gaining an hydrogen. What's the definition? It's a hydrogen ion acceptor. What does accept mean? It takes it. You're considered a base. This is a whole different definition of acid base. Yep. So let's take a look here. HS negative becomes S2 negative. So what happened to HS to make it become S2? Did it donate a hydrogen or did it accept the hydrogen? Donated, so it is a acid. That makes S negative 2 the what? Conjugated base. NH2 negative did what? Gained or accepted a hydrogen, and that became conjugate acid. If we did the reverse reaction, then this would be the acid and this would be the conjugate base. Yep. that make sense?
Why does like S2 the acid? How does the acid? How does it? Why is it that?
Because if we did reverse, what happens to the S negative 2? What does it do? It accepts an H,
Oh,
so it's the conjugate base. So let's take a look. This was very hard for CP Chem, but they're pretty quiet, so they didn't ask questions. I don't even know if they got it at the end or not. But H3PO4 to PO4 negative 3. H3PO4 to PO4 negative 3. Did it lose one hydrogen and did it change its charge by one negative? No, it didn't. It lost 3. So that's not what I said, did it? Is it? Is that car blue? Technically. What? The red car. What do you mean technically? Well, actually, no. Right? H3PO4, right? Every other color. I was waiting for you. H3PO4. What is the conjugate base of H3PO4? It would be what? H4 with a negative charge, right? That would be the conjugate base of H3PO4. What would the conjugate acid of PO4 negative 3 be? Right. Yeah. So these would be pairs and these would be pairs. These two are not pairs. How about HSO4 negative 1 and SO4 negative 2? Yep, these are good. Right? So that's all you're doing on that exercise. Here are some more formulas that you are going to try to determine whether it's what is the acid and what is the base. HF plus H2O yields F negative and H3O plus. Which is the acid, HF or H2O? HF, that means that H2O must be the base. Which is the conjugate acid, H3O plus or F negative? H3O plus is the conjugate acid, and this must be the conjugate base. Right? This is one of those things, again, that seems very simple, but if you don't practice it, it's not going to be simple on the test. HSO4.
Is it always the base and the conjugate acid that like pair up,
Yes.
and then acid and conjugate base pair up?
Yep.
And those are the ones
They
we,
basically
like,
have the same anion, right? They have the same
Okay.
anion because the only thing we're switching around is what element?
the hydrogen and one charge.
Yes. Yep.
Okay. Thank you.
You're welcome. So this substance is acting like a base. HSO4 acts like a base. What does a base do? Gains an H. So this is going to become H2SO4. What happens to the charge? It balances out, right? And this exercise, substance is acting as an acid. H2S is going to act as an acid. So what's an acid do? One more time. HS negative. Right? Down here, this is what you're going to have to do eventually is you're going to have to write balanced equations with these things reacting with water. So we have NH3, it's going to react with water. Water is H2O. What's NH3 going to do? Nope. What's it doing? It's following by being a base. So what's a base do? You got it. So that's going to leave us with NH4 with a plus. And what's left of the H2O? Yeah. But we actually write that as OH. Yep. Good, good. Down here, again, in each of the following, identify this stuff. Did I not put page numbers on this?
wait, how do you know that NH3 is going to do
I read the directions. Those stupid directions, right?
Oh,
So
How do you know when you should be taking out a hydrogen and taking out a charge versus
read the
adding a hydrogen?
I read the
adding a
directions.
charge? Oh,
says in the directions, this is acting as a base. This is acting as an acid. Otherwise, I have to have the whole equation to determine the two things, right? So what's NH3 acting as here? Acid or base? Base. That makes NH4 plus what? Conjugate acid. H2O is acting as a, maybe the top of the next one. Do you guys not have 7, 8, and 9?
Well, yeah, this is on, no, it's on the top of 11. Yeah, but it's numbers different. This is, that is the numbers, but it's top of 11.
Cool. So what's H2O acting as? Acid. That makes OH negative a what? Conjugate base. Boom, boom. Now, water can act as an acid or a base. You'll see that as you go through here. That substance is known, and a substance that acts as an acid or a base is called amphoteric. And there's a pH there, amphoteric. You want to, like, a dinner tonight or whatever you need. Mother, for dinner, I would like to have an amphoteric drink. Right? Get your science talk away from my meal table. No. Amphoteric acts as an acid or base. Can HNO2 act as an acid or a base? Right? It has an H, so it can act as an acid. Can it act as a base? What would have to happen? It would become what? Yeah, it's not likely, but that could happen. Probably not, though. Could NO2 act as an acid or a base? It can act as both? Tell me how it's going to act as an acid. Why can't it act as an acid? Doesn't have an H to give away. No. That's exactly why I did that. I wanted to make sure that you got it in your head, right? Yeah. Why it can't act as an acid. That's a good thing. To tell you the truth, today is a short lesson. Monday, I'm putting a video together, and Monday is hardcore math. We'll go over it on Tuesday. I'll also try to link a video where somebody that has a much higher budget than me and maybe talks better than me. You can watch either one. This is known as acid-base neutralization, or also known as titration. You can't let this one go on Monday. Like, please don't just think, oh, it's a digital day, whatever. Please make sure you go through it. Because if you don't, then we won't be able to get the last lab done. That's the key. Titration lab. We're basically going to take vinegar and we're going to find the concentration of it by using a concentrated base that we know the concentration of. It'll all make more sense on Monday. For this, please go down through this. I'll try to post the answers over the weekend. That way you have them Monday. You can look down through them real quick and then watch the video. Other than that, have a great weekend. Hug and kiss your mothers for Mother's Day. And if you don't have any questions, get out of here.
I'm still a little confused on like the pH like to OH thing, because I thought that the pH it would be less, but why is it like more?
I'm not sure what you mean by that sentence.
Oh, on like 2 on page 6. I don't know why I'm so confused by this.
Number 2 on page 6. This stuff?
Yeah, I just don't get why it's more. Like for the
So here's the deal: is we have the OH, right?
Mm-hmm.
So that means we are starting over here. So we've got to get to this pH. So it's a 2-step process. We've got to go from OH down to POH and then to pH.
Okay.
So
So
whenever
you do
we
the line and you,
find it,
uh,
in one number, and then we're gonna take 14 minus that number to get the pH.
oh, okay, I get it. I wasn't doing that 14 minus. I was like, I don't know, I was doing something weird.
No worries.
Thank-
I mean, that's why there's so many practice problems in that, because it is one of the things that you like, you have to repeat a bunch of times, and then you're like, oh, all you gotta do is follow the four-corner diagram, blah, right?
Mhm. Thank you.
You're welcome. Sydney, you got questions?
No, sorry.